Yeah? Ooh. Okay. So this is going to be a lot on Desmos. Okay. So what I'm going to do is probably have you do some graphing, and I'm going to do a lot of sketching so that people kind of see what we're doing. We're going to go back to section 3.1. Okay. And again, I don't know why, I mean the order exactly, but this is how it was showed to me. So, all right. So here's the deal with polynomials. There's different types of equations. There's what we call a factored form. And there is a general form. So a factored form looks like this. And those are little subscripts. So it's x minus c1, c2, c3, dot, dot, dot. Or you can have something like this. Okay, so A is a constant, all right? And here A, B, C are all they're coefficients, I should say. They're just, maybe I should say this isn't, well, that's constant. So these are all real number coefficients. And K is just a constant. It's just a number. Again, it's a real number. Okay, so there's your two forms of polynomials. They're either going to be in factored form or they're going to be in some type of general form. All right? And we're going to talk about C1, C2, and C3 and what they represent here in a little bit. Okay, so what are some polynomials and what aren't some polynomials? So anything in the form, for example, this is a factored form 1, okay? I guess they probably want us to use some function notation. All right, if I add some more stuff to this, they can be fractions, okay? You can have one or more of these things. You could have a fraction, you could have a root. All right, anything like that. It's polynomial in factored form, in general form. That's a polynomial. That's a polynomial. So anything that looks like that is a polynomial, okay? As soon as that x drops down to underneath, then it's not. And as soon as this becomes a function, like you couldn't have choose like a log, and have a log of x in there. That's not a polynomial. Okay, so it has to just be an x, and it can't look like that. Okay, that's not a polynomial. All right, so that's not. These are. So it's just basically got to have x's with some sort of numbers either in front, the coefficients, or written in factored form. The things that what we want to know how to do with polynomials is talk about the degree. Okay? So the degree is the largest power or exponent. So if I have one that looks like this, okay, we say the degree of that is just 1, right? Because it's just 4x, x to the first, all right? If we introduce this, then that has a degree of 2, because the highest power is 2, 3x squared. So then if we have this, what's the degree of that? 4. It's the highest power. It has nothing to do with how many terms it has. It all depends on the power. So when we're talking about polynomials, these, next Wednesday, all right, or even in next week when we do rationals, we'll call them by the degree. Well, that's a third degree polynomial. Well, that's a second degree polynomial. Okay, well, that's a fourth degree polynomial. That's what we're going to be using. So I want to make sure that when you hear that word degree, you can associate that with the power. And they're going to ask you about the degree. So the question would be then, well, what if we have this? Okay, what about that? Because, it has all power 1, 1, 1. Well, what you want to do then to figure out the degree, you have to put this in general form. But that would be a lot of work. So let's just count what the highest power would be. So we know we're going to have an x squared. And then we know if we took that x squared, we multiply that by this x. So that means we're going to have x cubed as our highest power. So what's the degree of that going to be? 3. Okay? So the degree of that would be 3. Even in a situation like this, degree is 3, because you have an x squared and then another x. All right? That's how those work. So that's the degree. Now, let's do this then. What we're going to do is we're going to graph some of these. Okay? So I'm going to give you something to graph. I'm going to have you graph them in factored form first. So we're going to graph these. So go ahead and get Desmos fired up if you haven't got it already. So that's the first one we're going to graph. So when you're done graphing it, somebody can tell me what shape it basically is, which you should be pretty good at because I'm pretty darn sure we did that already. And its x-intercepts. That's what I'd like to know. So what's the x-intercepts? negative 2, 1, and 3. Okay? So it probably looks like something like that. All right? It's just an N shape. We're going to get into those shapes a lot more on Wednesday. Okay, what are the x-intercepts? Negative 2, 2, and negative 3.
I didn't graph it. I was just going off the pattern I saw from the last one.
What pattern did you notice?
I think it was the opposite of what we had.
That's right. So when it's in factored form, okay, our x-intercepts are just the opposite of whatever those things are. All right. So remember I said we were going to go back. So if we go way up here to the top, and I'll come back down. These C's, these are your roots or x-intercepts. Okay. So C1, C2, and C3 are the x-intercepts. Okay, of the polynomial. So it's always good to have it in factored form because it tells you quite a bit about it. They also call these zeros and roots. So they have the same basic meaning. There is a little bit of difference between an x-intercept, a root, and a zero, but we're not going to get into that tonight. All right, that's a little bit more work, complication here. So that's what your C1s and C2s and C3s are. So once you know what those are, you can do a lot of different things. All right? So I'm going to pop back down here. And we're going to talk about analyzing the graphs. Now what they're going to do is they're going to ask you to analyze the graphs. Okay, and they're going to say, do steps 1 through 5 on page 205. They're going to have you go through. Here's all I want you to do with it. Okay, you should be able to figure out what the x-intercepts are. Well, now you know, because that's just where it crosses the x-axis. If it's in factored form, great, you can look at it and get it. If it's not, just graph it. All right. The other thing it talks about is turning points. Okay. Anytime that the graph loops and turns, then that's a turning point. So this is a turning point, that's a turning point, and that's a turning point. Okay? Those are all turning points. So anytime it kind of changes, remember how we talked about increasing, decreasing? So anytime that that happens, that's a turning point. Okay?
Basically our local min and local max, correct?
Yep. Okay? The other thing is end behavior. The end behavior is what's happening at the end of the graph. So this one is going down, so it's decreasing. This one's going up. You can't see. Oh no, that's going to come back down, didn't it? Made an M. Let me move them over. Okay? So at this end, it's decreasing. So we would say that the end behavior of this so as x approaches negative infinity, the end behavior is decreasing or approaches negative infinity. You can say it either way. Okay, so you can say decreasing or approaching negative infinity. As x approaches positive infinity, the end behavior of this is increasing. Or going to positive or negative infinity. God, what am I doing? Sorry, folks. Decreasing. I'll blame it on the drink stuff. Okay? So down and down. That's what it's doing. That's end behavior. What's happening at the ends. So when they want you to analyze graphs, all I want you to do is look at it and say, here's how many turning points it has, here's the x-intercept, here's what the end behavior is. Okay? That's all you have to worry about. Don't worry about following in any other directions. That's the only thing. Okay? Let's try this. Graph this one. Oh, let me change this to a minus. I better put a 3 there.
X minus 3.
Yep. So let me know when you get the x-intercepts. Got them. What are they?
-3.
Yep.
Got 1.
Yep.
Got 3.
3. Okay. Something unusual is happening at 1. Okay, so this thing should go like this. Am I right? Okay. So the question is that we got 3 x-intercepts, but there's something happening here at this one. Okay? Here it goes through it, but here, what's happening? It stops, huh? It bounces off, comes back down and passes through. Alright? Well, notice that that x-intercept, what's happening right here? So when it has a square like that, that's what's going to happen. It's going to hit that, touch it, and bounce off. So it just kind of kisses that x-axis, bounces right back off. Okay? When that happens, that is called a multiplicity of 2. All right? A multiplicity of 2. Because it hits there and bounces off. All right? Now, change that 2 to a 3. So change the 2 to a 3. How does that change it? Does it go through it? Or does it bounce off there? It goes through it, okay? So it's a little bit inverted with that, it goes through it. Okay, so that's a multiplicity of 3 because now we have a power of 3 there. Okay? So it's kind of hard to tell the difference between a multiplicity of 3 and a multiplicity of 1, or it's just normal. But there is a little bit of flattening probably there. Okay? It makes it look like a cube or a 3, multiplicity of 3. All right? So, one of the things they're going to ask you about is list of multiplicity. Okay, so if we wanted to get the x-intercepts of this, we would say the x-intercepts are -3, 1, and 3, and then we'd say there's a multiplicity of, if I go back to my original one, 2 at 1. Okay? They're going to ask you about that. And if it's a 3, then you're just going to say there's a multiplicity of 3. Okay? All right. Questions on any of that?
So whatever power it's raised to, if it's raised to a power, you put a multiplicity of 2. What if there's no power?
Just there is no multiplicity then. Yeah. It's just normal. Okay, so we're pretty good at graphing these. Okay, figuring out what the x-intercepts are. Oh, what about the end behavior of this? Let's do that. End behavior of this one. EB. So as x approaches positive infinity, what is this graph, or negative infinity? Let's do that first. What's the graph doing? Increasing. So as x approaches, we would say it's increasing. You can say approaches positive infinity. That's okay. What happens if x approaches positive infinity? What's this graph doing? Which one is it? Increasing, yep. Okay, or going to positive infinity. Okay? That's end, just whatever's happening at the ends. That's end behavior. So, can we go backwards? What if we wanted to write a polynomial with x-intercepts, bless you, of -1, 2, and -2. What would that look like?
X plus 1 multiplied by x minus 2 multiplied by x plus 2.
Yep. Now, suppose that somebody writes this down. Is that still going to be okay? We'll try it out and see.
Yes.
Yep. Yeah.
We'll just reflect it and stretch it.
Right, reflected and stretching. Okay. What really matters is these guys, right? This number in front, this A value, does the exact same thing as both same. Nothing different than when we had the parabolas and all the other transformations. It's either going to reflect it or it's going to stretch it. Okay? That's all that does. Nothing different.
Where did you get the -3?
I made it up.
Oh.
Okay? What if we said x-intercepts of -2, 1, and 3, but the degree is 4. Let's see if we can write that one. So what's it going to look like? So we have x. What are we going to have here? X plus, well, not plus 1. Because it's a positive 1, so it's got to be a minus 1. X plus 2 and x minus 3. But what's the degree of that we just wrote? We need a degree of 4, so what are we going to do with one of those quantities? Yep. There you go. That's how you solve that problem. Okay? Now that gives you a degree of 4. Pretty slick, huh? Okay? A lot of this stuff that you're just doing here in this section, you're just typing graphs in and, you know, analyzing them, looking at the x-intercepts. It's just really pretty much what we did right there. Okay? Is there anything you see on 208 or 209 that you're not, maybe wouldn't be sure of how to do?
So most of, it looks like 61 through 72 is just kind of reversing what we've done, just kind of reverse engineering. You kind of find out what your x-intercepts are, whether or not it's a multiplicity of 2 or 3, and then what the degree is, and then just kind of building a factor.
Well, they're really not going to be able to give you a multiplicity of 3 because it's hard to show that on those graphs, but the 2 isn't. Or I mean, the multiplicity of 2 is okay. Like I'm looking at 669, and that one has a multiplicity of 2. Agreed? Because it comes up to 1 and bounces off. Anytime it bounces off, that's going to be a multiplicity of 2.
71 would have
72? 72 would have a multiplicity of 2 at probably 0. Does that make sense?
Yeah.
What are you saying, Will?
So 71 would have a degree of 4.
Yes.
It's bouncing off the
Well, no, it has a degree of 5.
top.
Because you have 2 double roots, 2 multiplicities of 2, and then it crosses at 0. So that's a degree of 5. Okay. Now, on those ones, they're kind of getting specific with the A value because they give you a point, but I'm not going to worry too much about that. I just want you to come up with equations. We can talk about how to find A values a little later. All right. So when you're checking these and they're giving you specific A values, that's okay. Any questions on any of that? I think it's pretty. Okay, I told you it was going to be short. So, you know, I sent out a little announcement, so hopefully you guys got that. That's all you can come if you want. I just didn't want it to be, but yeah, I mean, that's pretty much all I got. Hope I'm disappointed. But, so I'll give you some more stuff on your project too on Wednesday. I'll be all back to normal on Wednesday and everything, so.